Or in the last lesson we started talking about short ways to do multiplication, and hopefully we've come up with a bit of a rule that when we have the same base and we multiply, then all we need to do is add the indices together. So we keep the base the same and we add the indices. Now sometimes there's going to be some coefficients involved, so it's going to be things like 3a to the 6 times 4a to the 7. In this case, you want to multiply the coefficients first, so let's just write that down. Multiply coefficients first, and so 3 4s are 12. A, keeping the base the same, and then you add the indices. So 6 plus 7 is 13, 12a to the 13. Alright, division. Similarly, hopefully you've come up with a similar rule. So here's the rule for multiplication. We add the indices. The rule for division is to subtract the indices. A nice short way to do division. And the same idea is we're going to divide any coefficients first. And then we're going to subtract the indices. So for example, if I have something like 56b to the 12 over 8b to the 4, that's a division. I'll do my 56 divided by 8 first, which is 7. Then I'll subtract 12, take away 4, and get b to the 8. So it's a nice simple rule, but you just have to remember what you're doing. Sorry, no, raising to a power. Hopefully you've got a rule for this one from last time, and you would have noticed that what you end up doing is multiplying the two powers together. So you get a to the n times m. So again, you want to raise any coefficients to powers as well. So you want to look for those coefficients. And then you want to multiply the indices. So I'll show you what that means as an example. If we have 3x to the 6 all raised to the power of 3, then I want to take this 3 and cube it. So I want to have 3 cubed, and then I want to multiply that x to the 18. Now 3 cubed is 27, x to the 18. Alright, here's some more examples just with a few more pronumerals involved. So here's a multiplication example. We're going to multiply the coefficients first, and 6 8s are 48. We're going to add the powers, but only those of the same base. So I need to identify where my a's are, and I need to add the two a powers together. So I get 5 plus 2 is 7. Then I need to identify the b's, and I need to add those two together to get b to the 6. So I'm only adding those with the same base. Similarly down here, division, again dividing out the coefficient, the coefficients, so 18 divided by 6 is 3. I'm going to subtract for division, and again the same base, and when it's just m on its own, that's m to the power of 1. So when I subtract, I get 3 take away 1 is 2, so m squared. Now n squared are going to cancel each other out. They're just going to go like that. 2 take away 2 is 0. The n has disappeared. And we'll look at what the 0 index means next lesson. This one here. Raise everything to this power of 3. I have to have the 8 cubed. I have to have p, 3 5s, 15. q, 6 3s are 18. Then I just simply need to work out 8 cubed, 512. P to the 15, Q to the 18. This one, just have to think about how we got to the answer. So we've started with A to the 8, B to the 5. It's down to A to the 7. Remembering division means subtract. So I've subtracted 1. So A to the power of 1, or just A. B to the 5 divided by something gives me B. Now B on its own, remember, means B to the 1. So 5 take away 4 is equal to 1, so it would have been b to the power of 4. Finally here, a little bit harder one. If 5 to the x is 7, find the value of 5 to the x plus 2. So what I want to do here is I want to work backwards and say 5 to the x plus 2, the plus tells me it relates back to my multiplication law. So that'd be the same as 5 to the x times 5 to the 2. So I can work backwards here. Now I know 5 to the x is 7. I know 5 squared is 25. And so I can just multiply them together to get 175. It's a bit of a harder one there to think about.